the second part of the morning session. So we have here McGregor Anna. I don't know if Anna is ready. Yes. Good morning, Anna. And the title, we cannot hear you, Anna.
Sorry.
There it is, there it is. The title of Anna McGregor presentation is Exploring Phenological Asynchrony between Avian Diversity and Vegetation in Temperate Deciduous Forests through Acoustic Monitoring and Camera Trapping. So please, Anna, thank you.
Hi, thank you very much for the opportunity to speak here. And actually, the first thing I'm going to do is introduce my colleague, Ross Barnett, who is fortunately able to join us today. And so I think he's going to deliver our presentation.
Yep. Oh. Hi there. Just share my screen. Yeah, so as Anna said, I'm Ross. This work formed most of my master's research, which was conducted in 2019. There's the main focus of the research was using ecoacoustics to answer a number of questions regarding phenology, biodiversity, and climate change. So, as I'm sure we're all aware, in temperate environments, as climate change progresses, we're experiencing warmer spring temperatures. These warmer spring temperatures can then facilitate an earlier emergence of deciduous vegetation in springtime. And that earlier green up process allows the earlier emergence of herbivorous insects in the wider insect food web. This can then cause problems for migratory passerine birds. In the majority of migratory bird species, the trigger for migration behaviours is photoperiodic, and it's therefore not affected by climate change. Phenological asynchrony can then arise between these birds arriving in their summer habitat and the environmental state of that habitat. Things like availability of insect prey could be lower or higher depending on whether or not they're arriving at the right time. So the aims of this research were firstly to determine what relationships exist between vegetation phenology and the soundscape more generally. This really became the main focus of my work, and I chose to test a number of different acoustic indices against phenological variables such as vegetation and photoperiod. The second aim was using acoustic monitoring as a detection mechanism for the arrival of migrant birds, to look at what factors play a role in maintaining synchrony with their summer environment. So green up of vegetation was tracked using camera traps, which were set up on a time-lapse setting. The R package PhenoPix was used to calculate a greenness index for each image. This is based on the ratio of red, green, and blue light in each pixel of the image. These scores can then be compared with date to find the start date of green up process and leaf emergence. So for each trophic level that I was looking at, and employed a different methodology. Vegetation, as I've discussed already, was tracked using camera traps. Invertebrate emergence was monitored using malaise traps and caterpillar frass sampling. And passerine bird diversity was calculated from historic ringing records and acoustic indices. This is a map just showing the 3 field sites I used, seen Blair Drummond and Battleby. They're spread throughout central Scotland, and they were all chosen because they've been long-term ringing sites for the British Trust for Ornithology, with at least 5 years of ringing data to calculate passerine diversity from. At each site, I used 4 camera traps alongside an SM2 recorder. All the camera traps were facing deciduous tree species, predominantly oak, beech, birch, a couple of hawthorn and sycamore trees as well. When I was looking at the analysis, insect abundance and biomass both were very strongly collinear with greenness. So these were excluded from further models. Generalized linear models were then created for the 5 acoustic indices I was interested in, with avian diversity, greenness, and photoperiod being used as explanatory variables. The phenological interval is calculated by subtracting green update for each site from the arrival date of each migratory bird species. So the first acoustic index that I looked at was the acoustic complexity index. Although significant associations were found here between ACI and avian diversity and greenness, the direction of these effects was highly variable and varied a lot of different sites. So it's kind of very difficult to draw conclusions about what mechanisms are underlying here. I then looked at the acoustic diversity index, which was found to be had a significant positive relationship with greenness, which could likely be a result of migratory bird species arriving as the green up process occurs, as they arrive and start singing, whilst the green up process is ongoing. Photoperiod, however, has a negative effect, which is slightly harder to account for because photoperiod, as well as triggering migration behavior in a lot of these species, also triggers the singing behaviors and other mating behaviors that you would expect to amplify the soundscape. Acoustic evenness was calculated next, which is the inverse equation of the acoustic diversity index. And as expected, it gives the inverse relationships. So here it's easy to say that the photoperiod increasing triggers more birdsong, but it's harder to account for the variation in greenness that we see here. I then looked at the normalized difference soundscape index, which was significantly predicted by avian diversity. However, like the acoustic diversity index, has very different directional effects at each location. However, photoperiod is strongly positively associated with this index as well. The final acoustic index that I looked at was the bioacoustic index, which I think showed the most promise as an acoustic index. It showed distinct positive relationships with both diversity and photoperiod, both of which were expected as from the what I've said already about photoperiod triggering birdsong behavior as well. And again, this index, like a couple of the others, shows this negative relationship with greenness. I think this could potentially be an effect of drops in singing behaviors in birds after they've mated, at which point some green up process may still be occurring, which would give us areas with a high greenness score but low bird activity on those recordings. Phenological interval varies really highly across the 10 migratory bird species that I looked at, with looking at the data for long distance versus short distance migratory species, it becomes clear that short distance migratory species arrive a lot earlier than their long distance counterparts. It's worth noting here that for the site on the left, Blair Drummond, and the site in the middle, Battleby, arriving earlier at these sites means that the birds are arriving further from the green update, rather than at the third site, Riverdennen, where the birds arriving earlier are maintaining a certain level of synchrony. This could be overcompensation. It could also be that there's perhaps an advantage to arriving early and getting good nest sites or finding mates before a lot of the other competition arrives. So my final conclusions from this research, it's clear to me that the bioacoustic and the normalized difference soundscape index show the most promise as indicators for avian diversity. Both of these show really clear links with seasonal changes, such as the change in photoperiod, which have tangible links to increases in bird singing activity. Phenological asynchrony should continue to be monitored. I think species that show growing lags from one year to the next in terms of their arrival relative to their summer environment may become conservation concerns in the future. Ecoacoustic technology does provide a really good methodology for investigating these questions around the arrival of migrant birds, especially with the rapid development of automated detection systems. So all that's left for me to do is thank my supervisors and the BTO and NatureScope for sharing data with me. I'll now take any questions.
So thank you, Ross. And I apologize, I was not aware that you were presenting instead of Anna, and but it was smooth, the transition between you two, because you are both here, and so I guess if there are questions, you are both invited to answer the questions if you pertain it relevant to that. I'm looking for hands, questions. There's a question from Jerome. Please, Jerome.
Thank you very much. Hello, thank you very much. A very nice study trying to address real ecological questions. I will have a question about the greenness index that you use with the camera trap. It's not acoustics, but could you develop a bit, please?
Yeah. So for each pixel in a digital image, there is the color of that pixel is controlled by a certain ratio of red, green, and blue light, which for every pixel in an image has a set ratio. And if you take the density of green versus the total density per pixel, and then average that out for the whole image, it gives you the this greenness index and relative greenness score compared to the other colors in the image as well.
Okay, thank you very much.
Are there any other questions from panelists or from attendees? I don't see anything in the chat, but you're invited also, attendees, to pose questions, comments. So if there is no questions, I maybe have a comment.
Sure.
You started with we started with the presentation of referring to climate change, of course, and you are right on the spot where things will be happening, hopefully, just in a few months, I think 5 months from now. On the 1st of November until the 12th, there will be the UN conference on climate change, which is highly, highly, highly expected from all sectors of society. That will be the conference right in Glasgow, where all the governments will gather to. It's the COP26, and it's the maybe after Paris is the most important one, because we are, as we were mentioning yesterday, we are right. The time is almost gone to be able to reverse the climate change catastrophe, which is highly expected if we don't really now change completely the pattern of our impact on the natural world and the biosphere. So you're right in the spot. So if you have a study, a developing study on species which are right there. So I wonder if you will have any way to interact with that conference. Those UN conferences are highly closed, of course, because those are congresses where political decisions will be made. So, but I mean, with our field and society, we are also working to raise awareness on what's going on in the soundscape. And so you have right there in Glasgow a study on that area. I wonder if you can find a way to bring a word from this science that is also screaming, hey, let's do something before it's too late. Soundscapes are changing. Soundscapes, species are moving, are adapting, and I mean, it's time to do something. So I wonder if you will have any way to interact with that very important conference, and you will need some support. Just share that with the community, and we can maybe bring a voice through, I don't know, through a talk, through an installation, through being out there saying, we are here, underline that this is happening. It's time to make decisions.
Actually, that's a super good point, David. And as you said, it is quite a closed conference. You know, it's for obvious reasons. Yes. There's a number of levels of interaction. And I have had some, there has been a request for some sort of short videos about climate change activities that are going on in the university. And I would certainly be, we're sort of in that holding period where they ask for expressions of interest, and then they're coming through asking for more material. But yes, I'll definitely
if you need the support of our entire community and of the society. I mean, it's science talking. It's science saying to the political decision makers to do something, because we are noticing things.
Yes. Yeah. No, that's a really, really good point. And hopefully we can act on it.
Perfect. So if there are not any more questions, I would go forward with the program. And we are